All right, so in our last video, we talked about how to break down a vector into its x and its y components, its horizontal and its vertical components. So we took a 50-pound vector at 30 degrees. We used these two formulas, and we found that the y component was 25 pounds upwards, and the x component was 43.3 pounds to the right. Now, I'm just going to remind you that if you've ever graphed anything in math class, that we know that this is the origin, and then we have 4 quadrants, and that anything that is pointing upwards gets a positive number. Also, if it's pointing to the right, it gets a positive number. If it's down, it gets a negative number. And if it's to the left, it gets a negative number. That should be familiar to you if you've done any kind of graphing. So when I look at these, now that I've broken them down, I'm going to go ahead and give a positive or negative to each one of these. And since this one's pointing up, it's positive. And this one's pointing to the right, it is also positive. So let's go ahead and do just one more of these, and then we'll add them together. So what if I had, say, a 30-pound vector that was pointing down and to the right instead of up and to the right. And let's say that it was at an angle of, let's call that 35 degrees. So I'm going to use these same two formulas right down here to break my vector into its sideways, that'd be x, and its up and down, that would be y components. So, using my calculator, to find the y is opposite, and according to this, and turns out it's the same up here, my y is going to be equal to the hypotenuse times the sine of the angle. So y is going to be equal to the hypotenuse, this is 30 pounds, times the sine of the angle is now 35 degrees. And so in my calculator, I will type 30 times the sine of 35, and I get 17.2. But I'll notice that since this is pointing downward, because this vector is slanting downward, I'm actually going to go ahead and give that guy a negative sign. The x is almost the same thing. It's going to be that hypotenuse, 30 pounds, but I'm going to multiply it times the cosine of 35 degrees. And so when I plug into my calculator, 30 times the cosine of 35, I get 24.6. And when I look at this guy, it's pointing to the right. Right is positive, so this is positive. Now, the reason that we do this is what the point of today's activity is. We are actually going to add these vectors up, and then we're going to make a new triangle from the resulting x and y's and figure out what the resulting overall vector is. So I'm going to make a little table here. One side for my x's and one side for my y's. So I'm going to look at my first vector, that was this guy. The x part of this vector was positive 43.3 pounds. This guy, it was positive 24.6 pounds. My y, for the first one here, positive 25 pounds. And my y for the second one is negative 17.2 pounds. So what I'm going to do is I'm going to add these numbers up down here. So this is my first vector, this is my second vectors, they're x and they're y, and I'm just going to take my calculator. And since they're both positive, I'm just going to add them. 43.3 plus 24.6. Gives me an x of 67.9, and I'm just going to remind myself that it's positive, which means it's pointing that way. And then this guy, 25 plus a negative 17.2, you can actually just subtract 17.2, gives me positive 7.8. And since it's positive, these are both positive numbers, this guy's going to be pointing up. Now, this is a much smaller vector than this one. So with these numbers, my last step is to go ahead and make a new triangle. So on another piece of paper, I'm going to make a new triangle with x and y's that I just found. So it's got a positive x, it's pretty long, of 67.9, and that was pounds. The y part was much shorter, 7.8 pounds. Now, I'm not actually measuring these, I'm just sort of eyeballing it. So again, if my friend walks over here and up here, and I walk slantwise, my travel is going to be here. We call this the resultant vector. This is what happens if I push 50 pounds on an object this way and 30 pounds on an object that way. What is the resulting overall force? It turns out it's that right there. So to figure out what R is, I need two steps. One is the Pythagorean theorem. The Pythagorean theorem says that if I take the legs of a triangle, each of them squared, I get the R squared. So I could say that that would be the x squared plus the y squared equals the r squared. Now, sometimes it helps to simplify the algebra before we do the problem. So if I was to take the square root of both of these, I'd get r. So I can rewrite this formula as r equals the square root of x squared plus y squared. So I am then going to go ahead and substitute these numbers in there. Square root of, I'm going to have to, in my calculator, find what 67.9 squared is, plus whatever 7.8 squared is. So in my calculator, I'm going to use the square root symbol, and then in parentheses, I need 67.9 squared plus 7.8 squared, and that is the length of my resultant vector. If you don't have parentheses on your calculator, you can do this part first, 67.9 squared plus 7.8 squared, hit equal, and then to hit the square root sign, and it'll give you the same answer, 68.3. And that is pounds. So that tells me that this here is 68.3 pounds. So that's a good chunk of what I need to know. But don't forget, I also need to know what this angle right here is. And our trig function for finding that says that the tangent of any angle, so I'm going to go ahead and do this. So that is the magnitude. Now I have to find the direction, because with vectors we also care about the direction. Turns out the tangent of that angle is equal to its opposite over its adjacent. Or if I wanted to get the angle by itself, just like anything else in algebra, to undo something to get the variable that I'm looking for by itself, you have to do the opposite of it. So remember, if you're multiplying, you divide by it. If you're dividing, you multiply, adding, subtracting. This is just basic algebra. Turns out that there is a function on your calculator called tangent to the minus 1. And that would actually make the tangent go away. So I can rewrite this formula as my angle is going to be equal to tangent to the minus 1, or inverse tangent, of my opposite side divided by my adjacent side. So this is just buttons in my calculator. I'm going to find the opposite side of that angle. So there it is, 7.8 pounds. I'm going to find the adjacent. That's right here, 67.9 pounds. And then in my calculator, I'm going to take the inverse tangent, and that will, inverse tangent of this fraction right there, and that'll give me my angle. So again, if you have a calculator that has parentheses, the tangent to the minus 1 is usually shift tangent or second tangent. And then I'm going to do that division problem in there, 7.8 divided by 67.9. This right there is what you want your calculator to do. So inverse tangent, parentheses, that fraction, and then we hit enter, and it shows me that this is a 6.5 degree angle, which is a really tiny angle, but if we look at it, it is a pretty small angle right there. So this is the direction of my vector. And so what I have just done is I've added those two vectors, the 50-pound and the 30-pound, and the result is 68.3 pounds pointing 6.5 degrees above the horizon. And that's it. That is how you complete vector addition problems.